Okay, let's interpret the graph of a function. You guys are going to love this. We love to have context and interpret things, don't we? All right, so Jay rides in a boat from his home to his friend's home in a neighboring state. So if you notice, he lives down here in Arizona, and the state line goes across Lake Powell. So he's gonna drive his boat to his friend's house, he's gonna hit the state line, and he's gonna come back. The graph of the function d of t equals 30 times the absolute value of t minus 1.5 shows the distance of the boat in miles from the state line at t hours. Assume the graph shows Jay's entire trip. So I want to talk about this graph right here. So here's a graph of that function. All right. So the function is up here. D of t equals 30 times t minus 1.5. If you notice, we've got our 1.5 right here. If we put context to this time is 1.5 hours. So here's what's happening. Our distance at time of 0, so before he starts driving the boat, here's his distance away from the state line. He is 45 miles away from the state line. So let's take a couple notes here. So the graph below shows us, what information can we get out of the graph? It shows us that Jay began his trip 45 miles from the state line. All right, so if we keep looking at the graph, so he's 45 miles from the state line. As time passes, do you see how his distance from the state line decreases? So after a half hour, he's only 30 miles from the state line. After an hour, now he's 15 miles from the state line. And at 1.5 hours, he's hitting the state line. So his distance to the state line is decreasing as time goes on. Once he hits the state line, now his distance is increasing, which means he's moving away from the state line. After 2 hours, he's 15 miles from the state line, so he's heading home. After 2.5 hours, now he's 30 miles from the state line. And after 3 hours, I'm just going to add in a 3 down here. After 3 hours, he's 45 miles from the state line, which means he's back home. So just to summarize a couple of things we just said, he hits the state line after 1.5 hours. And then Jay ends his trip after 3 hours when he's back home, which is 45 miles from the state line. So just a couple things to notice about the graph. These are key features that we talk about in Algebra 2 for sure. As time goes on, do you see how this function is going down? Would you say this is increasing or decreasing? And I know you guys would all say, well, it's decreasing because it's going down. So over here, that's where your function is decreasing. After we hit the 1.5 hours, as time goes on, we read graphs from left to right. We're decreasing, 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 and now we're increasing. The function is increasing. This 1.5 hours right there, do you see how we switched from decreasing to increasing at 1.5 hours, that's what we call a turning point of a graph. Turning point of a function. When does it switch from increasing to decreasing or from decreasing to increasing? It's called a turning point. Okay, so how far does Jay travel to visit his friend? Well, he starts out 45 miles away from the state line. So he travels 45 miles. It takes him 1.5 hours. He gets to the state line, and then he has to travel back home another 45 miles. So Jay's total distance traveled is 90 miles. Oh, I'm glad you guys are listening to this because that is hard to read. Okay, so part B, how does the graph relate to the domain and range of the function? So what's different about this absolute value function is there are no arrows on the end. So this is not going to continue forever. All right, so let's talk about the domain. The domain is your input. It's your x values. In this case, it is our hours because we're using an h as our input. As time goes on, that impacts the distance from the state line. So if you look at your hours, we start at 0 hours. We're up here. Our hours continue, and at 3 hours, we are back home. Well, not we, Jay. So our domain, the minimum value of our domain is 0 hours. The maximum value of our domain is 3 hours. So our domain is everything from 0 to 3. So we say 0 is less than or equal to h, which is our variable, which is less than or equal to 3. So there's our domain. All right, now our range is the output. It's the distance away from the state line. So the furthest away from the state line that we are is 45 miles. So our maximum range is 45 miles from the state line. Our minimum is when we're at the state line where we are 0 miles because we're on the state line. So our minimum range value is 0. And our range is minimum is 0, maximum is 45. And we can have any mileage in between there. So our range is going to be 0 is less than or equal to our distance. I'm going to say d of t because that's our function for distance, which is less than or equal to 45. And if you know the range is your y values on this graph, this is the lowest y value that we have at 0. This is the highest y value that we have, which is 45, so from 0 to 45. And then our domain is our x's, which are h's, but see how the furthest we go to the left is at a 0. The furthest we go to the right is at a 3, so our domain is from 0 to 3.